Good evening. Welcome to the QCIS channel. We're on this channel. I'm going to give you a daily dose of science, technology, engineering, and math. My name is Leon Jones, and this evening I'm going to talk about a branch of surveying. Now, when I did a surveying video a couple of weeks ago, I gave you an overview of the different branches of surveying, like topographical surveying, route surveying, construction surveying, even geomatics, which surveying is a subdiscipline of geomatics. Now, today, I'm going to talk about a type of surveying that goes with the field that I currently work in, and that's known as construction surveying. Now, when we deal with construction surveying, we're working with horizontal and vertical construction. Now, when we talk about horizontal construction, we're dealing with infrastructure such as roads, drainage. Bridges can be vertical or horizontal. So right now, I'll just stick bridges with horizontal since they deal with roadways. We can also deal with houses, subdivisions, which subdivision or site surveying is similar to construction surveying. Now, also before I go on, I apologize for the last video that I did on statistical process control. For some reason, the PowerPoint presentation didn't show up. I tried to upload it after I completed the recording of the video. It didn't work. Next time I do a video with a PowerPoint presentation, I'll make sure that I take the PowerPoint and click on the link for the PowerPoint in my download or from my document section, because what happened, the PowerPoint was actually there. What you saw is where I got the PowerPoint from. But tonight, I'm going to talk about route construction. Some people call it route surveying. Also, construction surveying, we deal with buildings, utilities. It's basically civil and architectural type infrastructure. Now, I'm going to share my screen, and we are going to talk about construction surveying. This is one of my favorite surveys because I work in construction. And what I like about construction surveying, this is one area where if you want to go into surveying, you don't have to have a license. Now, you will work out some computations like earthwork computations, cut and fill type of computations. Basically, you're dealing with everything that involves construction. All right, construction survey, as it's what it is. Construction surveying, and we are in the field of construction. And just want to say construction surveying is also a branch of surveying that you deal with construction of batter boards, slope staking, vertical and horizontal curves, as well as we get into the highway portion of construction surveying. But back to construction surveying. It is in construction. And remember, construction is one of the largest industries in the United States. Surveying is the base of it, and it's extremely important. It is estimated that 60% of surveying is spent in construction. Construction surveying. Now, this is from the state of Iowa, and I just mentioned it before, and that's in every state for the most part. A surveyor does not have to be licensed to conduct most construction surveys. Again, a surveyor does not have to be licensed to conduct most construction surveys. Now, basically, in the areas of property or boundary, or even getting into the legal aspects, that's where you want to be licensed. Construction tasks. The common task for the construction surveyor is you mark on the ground the locations of buildings, roads, pipelines, and other projects. Proposed locations, basically, like what you have here, is a plan. And your proposed locations are always shown on the plans, and they give distances and directions. And those distances and directions are marked by surveyors. Now, when we deal with any type of surveying in construction, you're going to see a lot of what we call construction stakeout. Now, construction surveys, again, we deal with proposed locations. They're marked by surveyors. Now, marks are typically wooden stakes or hubs. They serve as reference for horizontal and vertical control. And you can see right here, this is your control right here. You have a nail, you have your distances. You also have your cross and concrete pavement and your corner of building. Now, why do you need control? Well, you need some type of benchmark established so you can go ahead and stake out all of your building corners, your center lines of roads, your water lines. Those control points basically control the survey. They're basically fixed points. Now, they're very important because what if you're staking out a roadway or building corner and one of the stakes gets knocked out? Well, you have a control point that you can go back to put it in the same place where the original stake was. And some of the control points that you are going to see, you're going to see a dome, you're going to see a cross and concrete pavement. It could be a hub, it could be a nail and bottle cap, just like you see here. And this is what we call your control. As with construction surveyors, vertical location, proposed elevation of construction items. That is known as a grade. That's where we set what we call grade stakes, not to be confused with gradient slope or rate of grade, or which is a ratio of a change in elevation to a corresponding horizontal distance. What we're referring to is cuts and fills at vertical distances above or below the surfaces or below reference marks on grade stakes. When we deal with cuts and fills, we're talking about vertical distance above or below reference marks on grade stakes. Now, what do I mean by a cut and a fill? Okay, when we talk about a cut means, let's say we have a existing area of soil, and then we have a proposal. We can deal with a contour. Well, right now you have your land is right there. But if we have to put a new contour in where the existing one is, well, your cut may call for removal of soil or backfill, and your fill is going to be replacing an area with backfill. That's what we mean by cut and fill. And sometimes your grade may be a half a foot, a foot. It's whatever the plans call for, but that's what your vertical distances are. Cuts and fills. Construction surveys begin before construction actually begins, continues throughout the construction process, and it ends with as-built surveys. Now, before construction, there are benchmarks installed, and considerations are accuracy and location. Now, right here, when I was telling you about the dome, this right here is a geodetic dome. This is what surveyors use as a control point. Generally, you see a dome like this on a pair point of a bridge, or you could see them in the road. But these are points right here that establish everything that you're going to be dealing with from road construction to subdivision construction off this one point. And if you're running a traverse, you want to check right back into that point to check how accurate your survey is. Stake locations, sometimes the set at actual locations may be disturbed. Example, may be staked out prior to excavation of a foundation. It can also be replaced when the formwork for the concrete footings are to be built. Sometimes set at remote locations. Stakes for lines are offset. And here's your, looks like a 9-inch trench. And right here are your stakes right here. They're offset. Most of your stakes are offset. Like if I'm putting in a sidewalk, I may have a 10-foot offset. Your stake might have an elevation on it, and it might have a 10, looks like an apostrophe, which is a foot. And then if you see an O/S, that means offset. If you go back and review some of my previous videos, I showed you exactly what grade stakes look like in construction. When we deal with stake locations, offset lines generally parallel to the actual construction line, marked at full and half, sometimes quarter station intervals. Building corners are generally staked out with 10-foot offsets. Construction surveys involve the application of many techniques that I discussed in previous videos, such as traversing, angle measurement, and distance measurement. And this is what we call right here elevation, height of instrument, it's your angle. And this is what I would call, if you were staking out something, you're basically surveying on a slope. Now, when we deal with construction surveying, we must establish grade. And what does that mean? Or giving grade or grade staking. And what that is, it basically consists of setting marks such as top of stakes, nails and vertical surfaces, and keel marked at required locations or elevations. Again, let me go back over that again. Instead of using locations, I'm going to use elevations, because basically when we deal with a lot of surveying, let's say we're going off of a finished floor, there's an elevation attached to that. So basically, when we're giving grade or grade staking, that's going to consist of setting marks such as top of stakes, nails and vertical surfaces, and keel marked at required elevations. Keel is, when we use the word keel, it looks like a piece of crayon. That's what keel is. Now, when we deal with grade, grade can be transferred over relatively large offsets. Establishing grade, staking out buildings, and we also utilize slope staking. And here's what I mean. When you see these stakeout locations, well, this is your station. This is what they were talking about. Your station, 61 plus 20. Station's like a location. Now, when we have a C, we have left, this is center line, and this is right. And basically, we have a C, and that's going to be a cut. Like here, center line, cut 3.9. So that means if we were going to be excavating, we would be taking from the center line 3.9 feet of soil, or removing or excavating 3.9 feet of soil at this station 61 plus 20. Now we have cut 0.0. Although it's a cut, we wouldn't be excavating anything. Now here, we would be filling 3.3. Now, you also have information left or right. Cut at 20. Fill 6.4, 0.4 feet. Fill. Whenever you see a C that's cut, F is fill. Here's your slope, 1 to 1, 40 feet. See right here, this is what your profile looks like. And when there's cut, we'll be removing this. This is going to be your new grade right here, so they're going to have to cut. See where it says 40 feet? Your slope is 1 to 1. And when you're doing sloping, you also want to do benching. Always bench slope, because slopes have a tendency to cave in. I prefer 1 to 1 or 2 to 1, because you have to make it safe, because you're doing construction surveying. And we'll get into more of these calculations later on. I just want you to know what the stations mean, what C's mean, what F's mean. Slope staking is a procedure for giving line and grade for the construction of earthwork side slopes. Slope stakes mark the line of intersection of the side slope and the existing ground surface. This is called toe of slope for embankment, top of cut for excavation. Here's what they're talking about. You see right here, this is your center line stake. This is your fill slope stake. This is also your fill slope stake. So there you have your cut slope stake, your center line of stake. That's cut, your cut slope stake. Now, you see how this works? This is your proposed line, proposed slope. So what's going to happen here, they're not going to do any excavation. They're going to fill it. So that means they're going to fill this area with backfill. And this area is going to be set at a new elevation. Whereas here, they're going to take out existing backfill, and the cut is going to establish a new elevation as well. As we continue with slope staking, slope stakes placed on both sides of the center line, usually at 50-foot intervals along the route, marked with horizontal distance, either left or right of the center line, vertical distance from the existing ground at the stake to the elevation of the base. Now, what you have here, you have station number. All right, here's how the grade stakes are read. All right, you have your station mark 38 plus 00. Fill 5.4, 58.6 right, which means you have located at station 38, 58.6 feet to the right of center line. That's your offset. And then you're going to have 5.4 feet below finish. And this is what it looks like right here. Front, your offset right here, and this is your finish. And this is what it looks like on the back. The back has your station. The front has your cut, your offset. Again, when we deal with slope staking, we also have reference hubs, and they're driven beyond the actual slope intercepts or catch points out of the way of construction. Typically, they're 2-inch by 2-inch by 14-inch stakes. And here's what they look like. Here's what everything looks like. You have your instrument set up. You have your cut. You have your station. You have your offset. Here's your grade rod. These are your stations, your offset stake, your slope stake, and generally 1-to-1, your elevations. And this is what an actual construction stakeout looks like. And generally, I love construction stakeout because with construction stakeout, you're basically laying out the infrastructure. You have your computations. Not like boundary surveying where you're going to go out, you got to get everything on that particular plat of land. This is construction. And I find construction to be one of the best areas of surveying. Now, I'm not being biased. I do work in construction. I've done a lot of construction surveying. You have to do your calculations. You have to know what type of soil you're dealing with. You have to understand your grade stakes because you're dealing with construction equipment out there too. The contractor needs to know what those stakes say so he could either cut or fill at that location that the grade is calling for. Again, here's all the information right here. Your station. This is your finish, your 8.0. This is your offset. Here's your center. Your bottom number is your offset. That means 31 feet left of center. This is your, what we call your cut to your finished floor or your finish elevation. These are all cuts. These are your stations. Now you can see what it looks like. When you see this symbol right here, this is earth. And here are your grade stakes right here. Remember, 8 feet? Well, this is 8 feet down to the new finished area. This is it right here. 6 feet down. Now, 25 feet on the offset, 5 feet down. And see, it's better to show you what it looks like with a picture. Again, you look at this map right here or this profile. You got your distances. You got your slope. Your slope is 1 to 2. Now, in case you ask me, well, how did we come up with where did that 5 feet or 6 feet come from on the stakes? This is exactly what the stakes have. Now, generally, you have your station. Here, right here, is your cut down to your elevation that it's calling for. So what it is, your finished elevation. So it's calling for 8 feet. Let's say if I have an elevation of 100 plus 0, top elevation. Well, what is my finished elevation? Well, when I subtract 8 feet from my finished elevation from 100, my finished elevation is going to be 92 plus 0, because I'm going 8 feet down. I'm going to say I'm going to say 100 plus 100 minus 8 gives me 92. And this is what is written on a stake. You have your cut, 8.0. You have your center line. Your center line is always going to be 0.0. And you're going to have left to right. So the bottom number in the denominator, that is your offset. Your offset is 25 feet right of center and 31 feet left of center. And this is what's on these two stakes right here. And then you have your cut. Your cut is, this is how much soil down to that finished elevation that you have to excavate to get this elevation. Slope staking and blue tops. So after rough grading near final elevation, and the near finish grade is marked with blue tops, stakes 1 inch by 1 inch tops are driven to grade elevation, marked with a blue keel or blue spray paint, generally not offset. Slope staking blue tops. Now, here are notes from a DOT. DOT is the Department of Transportation. And what we have here, it says blue topping may be completed by either of two methods: level and rod, total station, and data collector. And from a DOT, note the area engineer will determine if project geometrics are such that the total station and data collector may be used for vertical control. Also, the area engineer will determine if his or her crew is competent to do blue topping, fully utilizing the total station and data collector for vertical control. When we also deal with construction stakeout, forgot one aspect, and we talk about staking out a pipe. So we have reference stakes. So within that reference stake, we have a reference hub that's placed at the end of the pipe, not the end of the flare or safety end. What we have is basically, generally, there are 2 stakes at each end of the pipe. Now the hub is driven flush with the ground and far enough from the pipe site to ensure protection during construction. And number 2, the guard stake. It's placed along the side of the hub, and it will contain the pipe information. And this is what it looks like. These are your pipes. Staking out pipe. All right, let's check some grade stakes out, front and back. All right, from this example, this information can be determined from the guard stake. It is 20 feet from the end of pipe. The pipe is at station 41 plus 50. It is a 18-inch by 40-foot CMP. CMP stands for corrugated metal pipe. That's the type. It has 2 flared ends. The hub is 1.5 feet higher than the flow line at the end of the pipe. Now let's go see what that looks like. Well, here's what you have for the stake. They told you the offset distance, 20 feet. Station, 41 plus 50. Now, when I mentioned 18-inch by 40-foot pipe, what am I talking about? I'm basically talking about the length of the pipe, which is 40 feet, and the size of the pipe. And each pipe is sized in diameter. You have a 4, you have an 8, you have a 12, an 18, a 24, a 36, 48, and the biggest one I've seen so far has been a 72-inch pipe. These are all in diameter. You have the type of pipe, CMP, the number of flared ends, and FLEND, that tells you it's a flare end. Now, on the back of the stake, it has C. When they say 1.5, that means you're going to have a cut of 1.5 feet. That's what that stands for. That's from this example right here. This 1.5 foot cut is, right now, it's higher than the flow line. So in order to meet the flow line, they're going to have to cut it 1.5 feet. Staking out a building, advisable. Got to do a property survey. So that means this is where you're going to get a licensed surveyor who knows how to do boundary surveying, because you have to locate the building lines or the setbacks. You have to locate boundary lines. So here you have a plat, lots 317 and lot 320, registered plan, Township of Markham, County of York, scale 1 inch equals 30 feet. Here's what it looks like. Here's your concrete foundation. Now, what are these? These are your building setbacks. These are your property lines. This is the plat right here. Everything is a building right here. So let me give you an example. The distance of this property is 50.09 feet. We have a north arrow from northwest to northeast. Southeast, northeast to southeast, 166.42 feet. And this is for lot 17, 50-foot property lines. And then for this property line, going from southwest to northwest, we have 169.41 feet. And the concrete foundation, 6.09 feet from the property line and 6.14 feet. And you have to understand this in order to read it. 6.1 feet from the property line, and from the front property line, the building is going to be set back about 26.67 feet, 25.74 feet. And then from the property line, 4.21 feet and 4.24 feet. And this is the road right here. Now, when you deal with a road, buildings all have a setback. Why? Because when it comes to the road, there's right of way. Now, what is that right of way used for? That's in case the road is going to be widened. Now, sometimes DOTs buy right of way. That's what eminent domain is for. But you see in this plat how all the measurements are done. Now, what do they mean by 1 inch to 30? Well, if you have an engineering scale, there's a 30 engineering scale. So measure 1 inch on that engineer scale, that's going to equal 30 feet. Again, staking out a building, stakes located at predetermined and perpendicular offsets. And when they mean perpendicular, they mean 90 degrees. You see, here are your stakes right here. Here are your offsets. Here's your baseline. And stakes are put at 90-degree angles. That's what perpendicular means. The baseline, what it looks like. In the 90s. Now, this is an old way of doing buildings, but back in the days when they were staking out buildings, they would use batter boards. And what is a batter board? Well, it's a standard method for temporarily referencing building corners. And generally, you have a horizontal wooden plank fastened to 2 vertical posts. And this is what a batter board looks like at all corners. These are your strings, your nails, it's your first floor. Batter boards are built offset from each corner. Opposite boards support a wire, string, or carpenter's line. Line delineates two exterior faces of the building. Lines are also leveled. They're string lines that are used to establish line and, of course, grade. As I move on here, and that's what the batter boards, this is what they actually look like. So here's your building right here. It's your building area. Here's your string line. Now, if you look at where your batter boards are, they're offset. Everything is offset. Not only are they offset, but they're square. And then you have vertical alignment of walls. And even you have batter boards along walls too. This is alignment for a wall or foundation of a basement. And generally, that's what construction surveying involves. Using grade stakes or slope stakes, you have your station, you have your offsets. When we deal with pipe, you have your type of pipe, your size of pipe, your length of pipe. Generally, when you're putting in pipe, say concrete pipe, some pipe, when you see different kinds of pipes, when you see RCP, that's reinforced concrete pipe. When you see CMP, that's corrugated metal pipe. Now, what do they mean by flared sections? Well, a flared section is, they look like wing walls. They're metal. They look like this. You got your pipe coming right between my, let's say my hands. That would be the pipe. And then about 45-degree angles, this is where my hands are. So the pipe would be the gap between my hands, and the 45 degrees, that's what a flared in section looks like. Generally, flared in sections are metal, and then you have concrete, and they're wing walls. So that's what you do with construction surveying. You do pipe, roads, buildings, utilities, you can do bridges, you can do subdivisions. In fact, one good thing about construction surveying that's better than the rest of the areas of surveying, you can stake everything out before construction and you come back, set stakes again, because construction is an ongoing process until the project is finished. I mean, you're the one who's ensuring that the person running that equipment is going to utilize the stakes in order to cut or fill to the proper grade. But once again, I've given you information on construction surveying. And again, when you do construction surveying, great thing about that area of surveying, you don't need to have a license. And if you enjoy construction, construction surveyors, or sometimes we call them field engineers, they're the ones that are always setting the baselines for vertical, horizontal construction. Then that concludes this topic on construction surveying. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some political and some social content, check out my main channel, the QCIS, the 401 Talk Zone Radio Show channel. Now, if you cannot find the 401 Talk Zone Radio Show channel or the QCIS channel on YouTube, you can check both of those channels out on Twitter. And for the QCIS channel, since it is an educational channel, also check that channel out on my LinkedIn page. Once again, thank you for listening and viewing this content. QCIS channel on construction surveying. On the QCIS channel, daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.